Here's the Predator 4000. Here I've got the brush unit removed. I've got the AVR removed. I've got the terminal holder loose here. Set of wires on this side is what hooks up to the plugs. These are the wires that come off the stator. This pair's got a sleeve around it, white black. You get 110 volts across that. The other pair's got a sleeve across it, red white. You get 110 volts across that. Normally this is hooked up so that the two whites are connected together, and you get 230 across this, 240, 110, 110. Now this is the connector that goes into the stator that is for the AVR, automatic voltage control. The two blues are the exciter wires when the motor is first turned on, and when it's running you get an AC output that goes with the AVR that powers the AVR. The AC voltage out of that is rectified and regulated, which drives the brushes over here. There's two slip rings down in here, just like a car alternator. The rotor spins around here, and they change the field voltage from anywhere to up to 90 volts. It's about a 38 to 40 ohm coil, so you can put a couple amps into it. Let's say it was 40 ohms, you'd get 2 amps at 80 volts DC. So there's DC voltage that goes into the rotor here, which is the field, which is spinning around. That controls the voltage. The RPM, of course, is 3600 because it's a 2-pole motor. So normally when this is all hooked up in the stock configuration, you get 230, 240 volts across this, and the two sense wires here, which are the white and the gray, you get around, say, 18 volts out there, AC. And that's the feedback that goes to the AVR. So when you got 230 volts across here, it's 230, 240, you got roughly about 18 to 20 volts off the white to gray. In the other video where I hooked these two pairs of stator coils in parallel, what happens is that you get around 100 volts across this if you had 120 across a pair. So what happens is that screws up the feedback to the AVR, and then you only get 24 volts out. One solution is to go through, and when they're in parallel, you could hook a transformer up on the output, and don't use these two wires, and then go ahead and feed the AVR directly with a sense voltage off a control transformer. You might be able to use a voltage divider too. I'm not sure what the input impedance is, i.e. how much current the sense circuit uses. That's another test I'm going to have to run. Again, I'm just showing the plug that goes to the AVR here. It's got two blues, got a white and a gray. Two blues, of course, the exciter voltage, which is first starts up the unit here. You have some residual magnetism, and that supplies some voltage to the blue that feeds the AVR. Then it goes ahead and feeds current back into the field, and then it builds voltage. That's why normally on a unit you don't want to have any loads connected when you first turn on, just to make sure you can build the voltage up. You can have loads hooked up, it's just that sometimes it may not build properly. It's better practice to go ahead and leave the loads off and you start it up, because I don't know, it may or may not work. I'll leave it at that. Again, this is the 120 volt. Each one of these pairs off the stator here, that's a white and a black. That's one pair. The white and the red is another pair. Those are in phase. Somebody else had mentioned they're not in phase. They're in phase. They have to be in phase because they add normally to be 120 or 240 volts. So in a normal configuration, the two whites are connected up front in the connector together. Got 120 again, 120, 240. When you connect these in parallel, what happens, the feedback is goofed up on the AVR, and that's why in the first video we had only 24 volts off there.